Okay, so this is the last definite integral from question 2. The integral from 0 to root 3 of x times the square root of 1 plus x squared dx. So based on what we saw in the first problem, when you have an a squared plus or minus an x squared, that is pointing us towards a trig substitution. But in this case, because we have an x outside of that square root, and x is the derivative of x squared, we have a product, and those two factors are related to each other via a derivative, which means that this might be a good candidate for u substitution, which is a relief because that's a lot easier than trig substitution. So I'm going to let u be 1 plus x squared, which means that du dx is 2x, which means that dx is du over 2x. And when you use u substitution in a definite integral, you also have to change the bounds of integration, because 0 and root 3, those are x values, and we're about to change everything to u's. So we need to figure out what is u of 0 and what is u of root 3. So when you plug a 0 into the formula for u, you get 1. And when you plug root 3 in, you get 4. So this becomes the integral from 1 to 4 of x times the square root of u times dx, which is du over 2x. So that's nice because then my x's cancel, and choosing u substitution was a good choice here. So this, I'm going to take the 1/2 out of the integral, and this is the integral from 1 to 4 of u to the 1/2 du. Rewrote square root u as u to the 1/2. It's easier to use the power rule. So this is 1/2 times the antiderivative of u to the 1/2 is 2/3 u to the 3/2, and evaluate that from 1 to 4. Okay, so if I plug a 4 in, u to the 3/2, the square root of 4 is 2, 2 cubed is 8, and 8 times 2/3 is 16/3. And then when I plug in a 1, and 1 to the anything is 1, so this is 2/3. So this is 1/2 of 14/3, which is 7/3.